Okay, let's talk a little bit more about friction. Friction exists whenever we have two surfaces in contact with each other. And no matter how smooth we make those surfaces, if you look at it microscopically, like in this diagram, you're always going to see that there's rough edges. And those edges will catch with each other, and that's what causes the friction. So they never slide smoothly across each other. Something like ice is very smooth, will have less friction opposed to like concrete where it's a lot more coarse and there's a lot more edges to catch. And we basically have two different types of friction. The first type is called static friction. And friction, the static friction is the amount of friction that exists when the two surfaces are stationary relative to each other. And the way we calculate friction is the friction force is equal to mu, the Greek letter mu, looks like a funny U with a little tail, times the normal force. So it depends on the normal force between the two surfaces. And this Greek letter mu is the coefficient of friction. And basically, it is a measure of how slippery the two surfaces are. So are they smooth like ice or are they coarse like concrete? And if you look in the textbook, there's a table with different coefficients of friction. So we calculate the amount of friction, the friction force, Ff, force of friction, by taking that coefficient and multiplying by the normal force, right? So the normal force, again, is the force exerted by the surface on the mass that's in contact with the surface. The other type of friction we have is kinetic friction. And kinetic friction is the amount of friction that exists when the surfaces are in motion. And you may have experienced this in your life if you've ever had to try and move something heavy like an appliance or move the sofa to vacuum behind it. It seems to take a lot more force when the object is stationary. And when it's in motion, it seems a lot easier. And it is a lot easier because when it's in motion, there's actually less friction. Up here we have the coefficient of static friction, and for kinetic friction we use a different coefficient. So when the object is in motion, there's a different amount of friction. And the coefficient of static friction is always going to be greater than the coefficient of static friction is always greater than the coefficient of kinetic friction. Okay, so let's take a look at a specific example. So here we have our block at rest on the surface. We know that it's exerting a force downwards due to gravity. And then the surface exerting an equal but opposite force upwards. That's our normal force. So the amount of friction that exists between the block and the surface is dependent on the normal force. So our force of friction here, because the block is not moving, it's static friction, and we would have to know what is the coefficient of static friction between these two surfaces. And then we could calculate the amount of friction. Now this is the minimum amount of force that you would have to apply in this direction to get the block moving, right? If I calculate the amount of static friction and I apply the same amount of force in this direction, these two forces would be equal and opposite. We'd have just enough force to start the block moving. So the static friction is the amount of friction required to get the block in motion. Once it's in motion, the coefficient of friction will decrease and you'll actually start to accelerate. You'll speed up. Now, because the amount of friction depends on the normal force, if we do anything to change the normal force, so for example, if instead of the block just resting on the surface by itself, if I exert a force downwards in this direction, this force has two components, a component in this direction and a component downwards. So I'm going to label these Fx, obviously, and Fy. This y component is actually increasing the normal force. I'm pushing the block into the surface, so the normal force now is a lot larger than it was before. And it's going to be the sum of Fg, the gravitational force, and this y component. So this force is equal to the sum of these two. And this, in effect, increases the amount of friction because we've increased the normal force. So now my friction force is larger as well. That's why it's always better to try and lift up, because when you lift up on the block, now the x component, which is accelerating the block horizontally, and the y component, which is lifting the block upwards, this y component actually decreases the amount of normal force, because now it's these two components upwards which are equal to the gravitational force. So now the normal force up, the normal force upwards is going to be equal to Fg minus Fy. Right? I've decreased the amount of normal force. And by decreasing the normal force, I decrease the amount of friction. Right? So if I lift up, I make it easier to pull this block. So you have to take that into account when you're writing your equation for the net force. You'll have an x component acting to the right, causing an acceleration, and a force of friction acting to the left, trying to oppose that motion. And this force of friction will change depending on the direction of the force that you're exerting, whether it's up or down. This friction force will change, and that will affect the acceleration. Okay, so that's a basic overview of friction. Try some of the questions from the textbook, and if you have any questions, you can always track me down in class.